Welcome to the LAKOS Pump Protection Sand Separator Training Seminar. My name's Tiffany Dawkins, and I'm based out of Portland, Oregon. I cover the Pacific Northwest and Western Canada for LAKOS.
And I'm Randy Delenikos, based in California and serving Southern California, Arizona, and Southern Utah and Nevada region.
Here's the rundown of what we're going to cover today. First, we're going to get into some of the key features to this unique product and also some of the value added by using these pump protection separators. Next, we're going to talk about sizing and selection. And lastly, we're going to offer some installation tips and, of course, a little bit of troubleshooting. We offer two different series of pump protection separator solutions. The first being the Sub K, which is going to be more for residential applications, all submersible pumps up to about 100 gallons per minute.
The Sub K series of sand separators is designed for low flow applications that you might see in a residential water well system. Each model comes with a sand separator shown here at right and an enclosure shell that puts the pump into the shell so that we can direct the water first through the sand separator.
The second is going to be the pump protection separator. This is for higher flow rates and all turbine pumps. We're talking 100 gallons per minute and more. If it is going to be used on a submersible pump that's higher than 100 gallons per minute, we offer a custom enclosure shell that the pump and motor will sit in so that the water will enter the separator before passing through the pump and motor.
The most important thing to understand with the pump protection separators is that its name says it all. It's meant to be applied when your pump has been worn out or has lost its efficiency due to abrasive sand. So when you feel that type of thing going on, this is an exclusive product meant just for that type of situation.
It's important to know that the pump protection sand separator is not going to be a one filter fixes all. Even though it's going inside of the well, it's not going to be removing those superfine particles you're seeing downstream. The purpose of the pump protection is in its name. It's going to protect the pump from wear that's caused by the large sand particles that are passing through your pump. General rule of thumb, it'll remove anything that settles in about a minute 30 to 2 minutes in the water supply. The pump protection sand separators are going to be using that centrifugal action to separate out those large abrasive sand particles that are causing that wear on your pumps. The benefits are going to be, it's going to extend the life of your pump, it's going to improve the efficiency, which is then in turn going to save you money on energy costs and maintenance. We can't stress it enough. This pump protection is going to minimize pump breakdown. It's going to improve efficiency, which is going to decrease your cost you're spending on energy and maintenance. And the benefit, it's using centrifugal action, which is going to be trouble-free because there's no moving parts, no screen, no filter, nothing to go in and replace. There's no routine maintenance that's going to be needed.
Typically, LAKOS pump protection sand separators extend the life of a pump by 4 to 5 times or greater, and that's guaranteed. In addition, the Sub K series actually pushes the water past the pump motor to help extend and improve motor life as well. Lastly, the Sub K series, they're injection molded plastic, so they're both lightweight and durable. This illustration shows how the separator is installed and how it works. Your pump is inserted into a pump enclosure shell and clamped tight to that shell. The sand separator is then installed below the shell. When the pump turns on and water is pushed to the surface, head pressure from submergence pushes water into the slots of the sand separator and sets up the spinning centrifugal action, which removes the sand from the water. Clean water spirals up the center of the separator into the shell, past the motor, into the pump intake, and up to the surface. The sand is captured in a chamber below, and when the pump turns off, a flapper valve relaxes and releases the sand deep into the well.
For larger submersible and turbine pumps, we offer the pump protection separator. It's going to satisfy a flow range over 100 gallons per minute, all the way up to the 3000s. It's going to work the same in operation. It's just going to be made of a durable carbon steel. And again, since it's typically going to be used on a turbine pump, the separator would just attach directly to the bottom of the suction. If it's going to be used on a submersible, We offer a custom enclosure shell that basically the submersible pump and motor would sit inside of.
The PPS series pump protection sand separator can be employed with either large turbine or larger submersible pumps. As the pump pushes water to the surface, head pressure from submergence pushes the water into the angled slots of the separator. That sets up a spinning action to remove the sand, the troublesome sand, from the water and down into the collection chamber, where a flapper valve remains closed while the pump is operating. The water then drives up the center of the vortex of the tornado and up into the pump and up to the surface. When either the pump stops or the accumulation of sand becomes great enough, the flapper pushes open and the sand is drizzled deep into the well.
If a large submersible is being used, we now offer a new shell kit. It's new for 2013, and we've decided to come out with this kit to be more economical and, of course, shorten the amount of time and lead times and transit times required if we're building all the enclosure shells in-house. So with this kit, you're going to be provided with the top and the bottom components needed to create this enclosure shell. The top would be sized to fit the pump's risers, and the bottom would be fit to the pump protection separator that's being used on the submersible pump. These two pieces will be shipped to you, and the installer would be required to provide the shell that the pump and motor would fit inside of. All you need to do is weld all these pieces together, and it's going to shorten the time needed by quite a bit.
Pump protection sand separators discharge the separated sand deep into a well. We understand the concern that this sand might fill up the well, but the truth of the matter is that doesn't happen. So oftentimes the sand that trickles down into the well also passes out of the well through the aquifer. It's moving water after all, and the sand doesn't really just accumulate. Imagine, if you will, the pump shrouds that people have used for many, many years, and that's not a concern about sand accumulation, and therefore you need not worry about the sand accumulation from a sand separator either.
LAKOS is always more than happy to help you with the sizing and selection of the right pump protection separator. Today we're going to talk about a few of the key components needed to select the correct model.
Proper model selection starts with the actual flow rate of your customer's pump. We can't guess at this. This is the most important ingredient. And once we've chosen the right separator, then we look to the column at left, for example, here in this illustration, and make sure that the minimum well ID is also possible. For the larger pump protection series, the PPS series, you may have several options for the flow rate, but pay close attention to the required minimum well ID, and you'll note that there's one model that's probably best for any given size. Where possible, try to use the single suffix lettered model, which will save you money. Otherwise, you're going to have to fit that separator to the well ID in order to make this work properly for you.
We're now going to talk a little bit about how these pump protection separators are installed.
With a small submersible pump in a well diameter of 5 inches or larger, take a look at the illustration at left. We insert the customer's submersible pump into our shell, then we attach the separator to the shell, and then we insert the assembly into the well just as you normally would just a pump. On the right, however, is the sub-pack series, which is designed for well casings of 4 inches, where we simply can't get a 4-inch shell into that same diameter. In that case, we use a pair of items called packers, and we use the packers in conjunction with the well casing itself to create a shell to isolate the pump in that particular area. It's important to note that the shell or the casing at that point cannot have any water coming into the well at that particular point. So we're going to attach a packer to the separator and install that first down the well. We release that assembly down the well. It'll stay in position because of the tight friction fit of the packer. We then insert the pump with the packer above it and slide that down the well, again on a tight friction fit. What you're going to do then is have the pump isolated between the two packers so that the water is still coming into the separator first and then going into the area between the packers, then into the pump intake, and then up to the surface. The water and head pressure does not come from within the well, but comes outside of the casing in the aquifer itself and still achieves the submergence and the head pressure that we're looking for to make this system work. These illustrations show how the PPS separator is installed for larger submersible pumps on the left or for directly to turbine pumps on the right. Note how the submersible pump on the left is inserted into the shell, and therefore all the water first goes through the separator before it gets into the shell. On the illustration on right, we don't need to enclose the pump because the suction casing makes it easy to attach the separator directly onto that fixture. For the PPS series, when installed directly onto a turbine pump, there's a standard riser size for every model. If that doesn't fit the suction casing size, you'll need to provide an adapter. Once you've got that unit attached to the suction casing of the pump, then attach the flapper valve to the bottom. It's the black rubber piece that will help control the accumulation and the disposal of the sand after separation. For a pump protection separator installed onto a large submersible pump, we first must insert the submersible pump into a pump enclosure shell. We start by using the riser assembly at right, and that attaches to the pump itself, the pump's riser. Then the pump and riser are inserted into the shell. There's a hole provided for feeding the wire through that riser assembly. Next, the separator is attached to the bottom of the pump enclosure shell. Then, the flapper valve gets added to the bottom of the separator. At that point, the entire assembly may be lowered into the well as you normally would. For PPS separators with a single suffix letter, such as model PPS 325G, these models have an adjustment collar that can be used to fine-tune the separator to the actual flow rate of a given application. Follow the instructions on the literature that shows you what position to place that adjustment collar given the actual gallons per minute of the system. LAKOS offers an array of promotional materials and detailed product brochures that enable you to be able to present these products intelligently and clearly. Give your LAKOS regional sales manager a call and ask for quantities of this to use in your sales presentations.
Thank you for joining us today. We truly hope you found value in this training session, and we encourage you, if you have any further questions, please contact LAKOS toll-free or via email, or contact your regional sales manager. We'd be more than happy to help you, and we very much appreciate your time.